Hey, how's it going everybody? Lead Cypher here. In this video we will attempt Troll 1 from Vulnhub. This is a beginner to intermediate machine and has a lot of rabbit holes. I'll skip straight how to root this machine and now let's get going. As usual we start with discover to get the IP address of the machine. And it's running on 192.168.110. Then let's do a map scan, -SS for TCP sense scan, -A for aggressive scan, and -ON for normal output to a file called a map scan. And we have 3 ports open, SH, HTTP, and FTP. Now let's run a derp scan. As you can see here, this machine has verbose.txt file and a secret directory, but both of them are rabbit holes. Now from the mmap scan, we know that this machine is running FTP on port 21 and it's vulnerable to anonymous login. This vulnerability allows to log into the FTP server as the anonymous user with any password you specify. Let's do that. To log into the FTP server, type FTP followed by the IP address of the machine. Name is anonymous, password, anything. There's a PCAP file. Let's download it and analyze it with Wireshark. To download the file on your local machine, type get and the name of the file. Now open it in Wireshark. Right click on any TCP packet and click on follow TCP stream. With up and down arrows you can switch between streams. And here it says you almost found that super secret dir LOL. Let's check this directory. This looks like a binary. Let's download and play with it. It's in a 32-bit ELF binary. Let's execute it to see what it does. Type chmod +x and the binary name to add the execution privilege to it. Now execute it. And it says find address hex 0856BF to proceed. Let's check if this is some sort of a directory. And indeed it is. We have here 2 folders. Let's check them. This looks like a usernames file. Let's grab it. This file is a rabbit hole. It took me a while to figure it out. I'll explain later. Let's just proceed. We know from the mmap scan this machine is also running SSH on port 22. So as usual, let's brute force the SSH login with Hydra. Type in Hydra, then the SSH followed by the IP address, -L for the usernames file, -P for the password file, -V for verbose output. Run. But we are not gonna get anything. As I said, the password file is a rabbit hole, and turn it out that password is the name of the password file, which is pass.txt. So let's fix that. Oh, you might get connection refused because we made too many login attempts with Hydra. There we go. The username is overflow and the password is pass.txt. Let's SSH to the server. Now, there are 2 ways to prevent to the root user. The first one is by using a cron job, and the second one is by using some sort of a kernel exploit. Let's start with a cron job method. There's a file in the var log directory called cron log that tells us that there is cron job runs every 2 minutes, and its name is cleaner.py. Let's find out where this file is. Type locate followed by the file name, and it's in the liblog directory. By the way, your SSH connection will be killed repeatedly due to another cron job that we will find out about later on. So here's what we're gonna do. We'll create a simple C program that sets the user ID to 0, which is the root user ID, and the same thing for the group ID. Then after setting these permissions, we will execute bin bash to get a shell. Then we will compile this C program with gcc, the GNU compiler. Now we will use the cleaner.py file, which is owned by the root user, to execute a command for us. We're simply gonna make the root user own the C program that we compiled. Then once this program is owned by the root user, we will give it the setuid permission in order to execute it with the root user privileges. Basically, we will convert this C program to a setuid binary. Again, if you don't know what the setuid binary is, it's a binary with which you can run with the privileges of its owner. So, chown root :root to make this binary owned by the root user and the root group, followed by the full path of the binary, then semicolon to terminate this command, then chmod 4777, 4000 for the setuid permission, and 777 to make all users read and write and execute this binary, the root user privileges. Now save and wait for 2 minutes. And there we go, the binary is owned by the root user and has the setuid permission. And all users can read and write and execute it. Again, once we execute it, the user ID will be lowered to 0. And the same thing goes for the group ID. Then after that, bin bash will be executed to get us a shell. I hope that's clear to you guys. Anyway, run cron tab-l to see all active cron jobs. And we have 2 cron jobs, cleaner.py and lmao.py. And I'm pretty sure that this is the file that repeatedly kills our SSH connection. It prints times up LOL, then it pipes that to wall to broadcast this message to all logged in users. Then it kills our connection. Now the second method is pretty straightforward. There's a cool SSH utility called Linux Exploit Suggester. This script suggests you exploits and CVEs that the kernel might be vulnerable to. I grabbed this script on the machine and ran some of the exploits that it suggested, but the only one that worked for me was the CVE 1328, the overlayfs exploit. Download the exploit from this link. Open it with Vim to see how to compile it, and you can easily compile with gcc. gcc, name of the exploit, and lowercase o for output name. And that's it. I hope you guys learned anything useful from this video. Leave a like if you liked it, and don't forget to subscribe. And as usual guys, I'll see you in the next one. Peace.